Naming coordination compounds. The cation is named before the anion. Within a complex ion, the ligands are named first in alphabetical order, and the metal atom is last. The names of anionic ligands end with the letter O. Neutral ligands are usually called by the name of the molecule. The exceptions are water, which is called aqua, CO, carbonyl, and NH3, amine with two M's. When several ligands of a particular kind are present, the Greek prefixes di, tri, tetra, penta, and hexa are used to indicate the number. If the ligand contains a Greek prefix, use the prefixes bis, tris, and tetras to indicate the number. The oxidation number of the metal is written in Roman numerals following the name of the metal. If a complex is an anion, its name ends in 8. Here are the names of the common ligands and coordination compounds. Some of my favorites are hydroxo, OH-, carbonato, CO3, 2-, and oxalato, C2O4, 2-. What is the systematic name of Cr, H2O taken 4 times, Cl2, and Cl outside the complex? It's going to be something chloride. Notice that there are 4 waters. That would be tetra, aqua, and 2 chlorines, dichloro. So it would be tetra, aquo, dichloro, chromium 3 chloride. Write the formula of tris ethylene diamine cobalt 2 sulfate. Notice the prefix tris. It has to be used because ethylene diamine has the prefix di in it in the name. So to avoid confusion, we use tris, not tri. The formula would be COEN3 because there are 3 ethylene diamines, and the sulfate is outside the complex. Structure of coordination compounds can be linear with a coordination number 2, tetrahedral or square planar with a coordination number 4, and octahedral with a coordination number 6. Stereoisomers are compounds that are made up of the same types and numbers of atoms bonded together in the same sequence but with different spatial arrangements. Geometric isomers are stereoisomers that cannot be interconverted without breaking a chemical bond. Here is cis-platinum ammonia chloro complex, and here is the trans complex. Notice that in one case the ammonias and the chlorines are on the same side. In the second case they are opposite one another, cis and trans. Here's a hexacoordinated complex, the cis complex, and the trans complex. The cis and trans are the chlorines. In the first case, the cis, the chlorines are on the same side, and trans, they are opposite one another. They have different color compounds. Are these additional geometric isomers? Optical isomers are non-superimposable mirror images, like your hands. If we put a mirror between the 2 compounds, cis, the optical isomer is called chiral. In the second case, the trans cobalt complex, they are not optical isomers. They are referred to as achiral. Chiral molecules are optically active, which means that they rotate the plane of polarized light. If we put a solution in a polarimeter tube and pass polarized light through it, it will be rotated.